If the two coins are placed on a horizontal disk which is moving at a constant angular velocity, so which coin has a more tendency or probability to move out of or to move from that horizontal disk? You will get idea by looking the solution of this question. So what we are looking in this question is there are the 2 points. There are the 2 points, the point y and the point x. So this is point y and point x taken on that horizontal disk, which is moving with a constant angular velocity. So means it is not changing. It is covering same number of rotations in every unit time, in every 1 second, what we can say. So the point y is at a distance L from the central axis. So this distance is L from the central axis, whereas the point X is at a distance 2L placed from the central axis. And if I show you it's the front sorry, the side diagram. So this is the point Y, which is at a distance L, and this is a point X, which is at distance 2L from that. So the question is, if the point Y or any object which is placed at a point Y has a speed tangential velocity V, then what will be the velocity of the point X? And what will be the centripetal acceleration of the X if the centripetal acceleration of the Y is A? Now you know that the centripetal acceleration is always directed towards center. So I mean to say this is, let's say A is the centripetal acceleration. So if you are thinking that why I am showing you this direction of velocity for the y, so the reason is because when the disk is rotating in anti-clockwise direction, so this point is completing is, just imagine this circle, right? So this velocity v is the tangential velocity. Okay. So what is a velocity at of x, point x, which is placed at a twice a distance as comparable to the y? We can obviously apply this equation. V is equals to r omega. Why? Because this is a linear velocity and angular velocity. They are linked with each other by this equation. So for the for the y, we can say v can be written as equals to L omega, and omega is the constant. So what is for the y? For the x, it should be equals to 2L into omega. So that should be equals to 2 into L omega, and that we can write 2 times V. So it means that the any object if you place at a point X will have a more probability to move out of the disk, because it is moving, its tangential velocity is 2 times more. So it means for X, now I should show you this 2v like this. Okay, because its circle is a bigger circle and it have a more velocity, but once again centripetal acceleration is towards the center. But what will be that acceleration? I want to give you first of all a fundamental concept about this. We know that the centripetal acceleration is equals to v squared over r, but there's another formula that says r omega squared. But why, how can we use these one of them? Because look, for this specific situation, we know that the angular velocity is not changing. So we can drive, we can write here r omega over r, and right after this, you can prove that it is equals to r omega squared. So we will choose this equation because angular velocity, the is uniform. So it means that, so if for y we say A is the r omega square, which we can write also L omega square. So it means that for the x, it can be written as 2L omega square, because omega is a constant angular velocity. So that should be equals to, once again, it is very easy to guess that it is 2A. So which means that it should be 2V and that should be 2A. So option B is the right answer, which says 2V and 2A.